I will present today a little bit on the new team hemoglobin measurement brief. Before that, I have to say I have no conflicts of interest. Okay, so this brief came out with the new WHO guidelines on how to determine anemia on a population-based level. It's made by the team, so the Technical Expert Advisory Group on Nutrition Monitoring. And this technical brief describes the current best practices for hemoglobin measurement, providing guidance to help plan or implement field surveys to assess anemia at the population level. The working group actually came up with three questions which are mentioned in this brief. The first one is, what are acceptable alternative methods for assessing hemoglobin concentration compared to reference standards? Then the second one is, what are the key quality control issues for accurate diagnosis of anemia? And the third one is, what blood source to use? And that's something Lisa will touch on later. So I changed it to another question, which is one further, yeah. What is required for proper venous blood collection? So I will go through the brief, which is also available and highly recommended to use in your trainings. And I will also weave in a little bit of my own experience when giving technical assistance to survey countries. For example, at the moment for Malawi, where they are doing the DHS field collection at the moment. One further. So first of all, if we look at the hemoglobin assessment, it's really important to think that we have pre-analytical factors we have to think of, the analytical factors and the post-analytical factors, which are influencing your hemoglobin assessment and your anemia assessment. If we look at the pre-analytical factors, we have the extreme environmental conditions you have to think of in the field, low resource environments, poor infrastructure, your source of blood collection, but as I said, Lisa will go into this a little bit further in the next session, and quality of your trainings. Then we have to look at the analytical factors, so the accuracy of your measurements, the reproducibility of the result, and the quality control needs. And this is also something Laura will go into a little bit further, and also adding there the post-analytical factors, which are the new adjustments and measurements when you have collected your data. One further, yeah. So first of all, how should hemoglobin concentration be measured? Well, the golden standard is to look at the hemoglobin method, but as we all know, we most of the time look at hemoglobin. So in the brief, we say that the clinical laboratory setting, the hemoglobin concentration is generally assessed by an automated hematology analyzer. It's very reliable and accurate, but as we also already shared, I think yesterday, it's quite expensive and generally not transportable to the field. And also it requires a cold chain to maintain from the field to your analyzer, which is often not feasible and quite expensive to add to your survey. Then furthermore, if you use the automated hematology analyzer, you don't get a direct report to your participant. So therefore, in the brief, they asked, one further, what are the acceptable alternative methods for assessing hemoglobin concentration compared to a reference standard, which is the automated analyzer, especially in population-based surveys. And then, of course, we come to the point of care hemoglobin meter. I don't know why there's a black box there, but you all know a HemoQ, I think. And of course, these are have some advantages to use in the field. First of all, they are calibrated against the international reference standards by the manufacturer, and therefore they don't require any additional calibration in the field. So they're really field and user-friendly, they are portable, and often they are a little bit less expensive to use in terms of the HemoQs or the quality controls you are using. And as we have seen over the last days, you can also use them for the venous blood, which we are collecting nowadays instead of the capillary blood. However, if you want, click one. I think it is good to look in your country what kind of lab assessments you do have available. And for example, if you look at Malawi, they gave us a really good overview of all the automated analyzers which were available and all the other machines which were available in their country setting. And I think that's also something which came out of the discussions from yesterday, to look at what is the capacity within your country, but also to share capacities over different countries and see what is available, for example. Okay, you go one back. I'm still on the previous slide. Thank you. What is available in your hospital setting, but also, for example, in universities. So you are well aware of the availability. But still, one of the main problems there, if we look at the automated analyzers, is that there's really a lack of proper training and also the usage in terms of quality controls. So then we can look at, one slide further, the best practices. What is at the moment the best practice to collect the venous blood sample using either the automated analyzer or the point-of-care hemoglobin meter, so the HemoQ. I think we might all know, but let's just go through it a little bit. First of all, the venous blood needs to be collected by a trained phlebotomist. And we come back to this a little bit in a further slide. And then the venous blood is collected in the tube and inverted 8 to 10 times. I know it sounds maybe silly, but yeah, it's really important and often forgotten, because the tube, which is containing the anticoagulant, needs to be well mixed with the venous blood collected. Then, if you look at for the HemoQ, you need to collect 2 or 3 drops of that blood out of the tube onto your parafilm. You need to fill up the cuvette in a well manner, and then wipe it off and insert it in the HemoQ by 15 seconds. But when this is all done, one click, I think they are discussing. Click. What are then other key quality control issues for the accurate diagnosis of anemia? Well, first of all, I think for the HemoQ, if we click, yes, thank you. For the HemoQ, there are some studies which show, if you look at the different models, some positive or negative bias compared to the automatic analyzers. But this is still research which is going on, and it's not taken up in the brief. And it might be possible to correct for these measurement errors. And I think this is something just to share, like there's always still a lot of research going on how to use the HemoQs correctly and how to make up for these measurement errors. Anyway, if we then look at the analytical factors which could potentially be addressed on a field-friendly quality assurance framework, this comes back to when we do the trainings and for collecting these venous blood samples and using the HemoQ, it's really important that you also report correctly on the machine maintenance and which quality control solutions, so the hemotrolls, are used in terms of when were they opened, what was their expiration date, and how are the readings from these hemotroll controls. And it's not only for the monitoring in the field, but also for the data assessment later, which Laura will come back to. So training is really important, and I think this is something we often might forget, because we all think we are able to use a HemoQ correctly, and we think that we are all able to measure the hemoglobin reading from the HemoQ correctly as well. But this is often actually not the case. And one click. Something we see often within trainings and which does affect the data and the accuracy and the reliability of the data of the field workers, is that if you look at false low hemoglobin measurements from the HemoQ, it's when there is too much alcohol used when the blood sample was taken, so the alcohol is coming into the blood tube, or if the microcuvette, the small microcuvette, contains the air bubbles. So you can see in the light, actually, it's not filled up correctly, which will give you a lower measurement. We can also have some false high measurement of the hemoglobin. If the microcuvette is not filled up correctly and it's not mixed correctly with the reagents in the cuvette. If the microcuvette is wiped too much, so too much blood is taken out when it's wiped clean before putting into the HemoQ. And also when the blood drop from the venous blood sample onto the parafilm is already clotted before the HemoQ was filled. Then we still have some other HemoQ dependent errors, and this has to do with the humidity in the field, your temperature. So if the temperature is higher than 37 degrees, your HemoQ will not work correctly as well anymore. And also the type of HemoQ used, because some of them, they require a really short reading time. So you have to do everything within a minute, while others might not. And then something else which we saw also, for example, when we did some of these quality assurance trainings within Malawi, is that when we were using the HemoQ really intensively, because we went through this measurement in the trainings, that the HemoQ was giving different results over time. So it also shows that sometimes maybe you need to have actually a little bit of time in between the readings in order to read correctly. And I think this is something which we are not always aware of, and it's also really good that we get this kind of data out of field trainings and field measurements, because then we can touch upon this later again as well. So then, can you go one further? To wrap this up, how to collect proper venous blood samples. So these are all the steps which are also shared within the brief, and I think it's really important to share this in your trainings as well, and you can put all these tables and figures in your training material. I will not go through them all because I don't have time, but what I think is really important, first of all, is the training. It's also the availability of all your field equipment, field items which you need, and then training with proper population. So if you're taking venous blood samples of children, you really need to train on children to see who is able to do this kind of performance, because otherwise you will have maybe low response rates in the field, because it's difficult to take these samples. And then something I think which I want to share, which we see in Malawi at the moment, where we are taking the venous blood samples, is the sensitization and the communication of how to take these samples in the field. Because, as we all know, we are taking now a tube of 3 ml for only 2 or 3 droplets which we use for the HemoQ assessment. And on one hand, if you then dispose within the household, as you want to do, because you want to show that you're not taking any of the blood with you for further analysis, a lot of the households question, why are you taking so much blood for only such a small amount and such a small assessment? So I think we really have to come up within the community here with proper communication material and proper ways of communicating why we are doing this now, because we actually see that there are a lot of households which decline at the moment because of this, and also because there's a lot of different communication between households, and you know how it goes. The information travels from cluster to cluster. So sensitization of your communities and within your countries is really, really important before field teams are coming in to take this kind of venous blood samples. Okay, so then to wrap up, can you go? So what can be done in country? As I said, I think it's important to look at what kind of equipment do you have in country and how to use this properly, which also requires lab capacity building. The importance of training, although you think that you have people who are well and experienced phlebotomists. You have people already done survey rounds where they have used HemoQs. It's always important to train and retrain. And the understanding that all the different factors which I go through here in the presentation and also in the presentations which are coming are influencing the outcomes of your hemoglobin and thus your anemia results. And I think this is something we are not always touched upon, that actually all the steps are having a potential influence, and also something which is maybe good to share within your country, but also between the countries. It's not only about the data, it's also all those steps before. So please share your best practices or your challenges or other experience you have, so we can all come up with some good and well-maintained results and data.